In a building in Richmond, California, 18 slabs of metal sat under polishing machines that ran for months at a time. Each one was a hexagon, 1.33 meters across, and each one was being ground toward a shape that was, measurably, wrong. Not by accident. The error was calculated in advance, to the nanometer, and written into the work order. The most expensive telescope ever built was being deliberately made incorrect.
Start with a low ridge in western Utah, about 130 miles southwest of Salt Lake City. Spore Mountain. The rock there carries bertrandite, a dull mineral that holds beryllium, element 4, one of the lightest metals that exists and one of the most difficult to work with. NASA wanted it for something it refuses to do. Cool ordinary metal towards absolute zero, and it contracts and warps and keeps moving in ways you cannot fully predict. Beryllium mostly stops. Below roughly 100 Kelvin, it goes dimensionally quiet, and for its weight, it is about 6 times stiffer than steel. It is also poisonous in a permanent way. Inhaled dust can scar the lungs, a condition called chronic beryllium disease, and there is no cure. So the shaping was done inside sealed enclosures in Cullman, Alabama, with the air scrubbed and nobody breathing near the work. Each blank arrived weighing around 250 kilograms. Machines cut away more than 9/10 of it, hollowing the back into a honeycomb of ribs about 1 millimeter thick, until what remained weighed roughly 20 kilos.
Here is the problem the polishers were actually solving. Beryllium is stable when cold, but it is not perfectly stable, and every segment moves a little differently. Its own grain, its own internal stress, its own way of flinching when the temperature drops 250 degrees. You cannot correct that in orbit, so they measured it instead. Each finished segment was crated and driven to Huntsville, Alabama, to a facility at Marshall Space Flight Center that could take a large object down to around 30 Kelvin. The cool down alone took weeks. Cold, in vacuum, interferometers mapped the surface and produced a picture of exactly how that individual mirror had deformed, in bumps and dips measured in tens of nanometers. That map went back to California, inverted, and was polished into the warm glass, the precise opposite of the error carved in so that cooling would cancel it out. The technique has a name, cryo-null figuring. Then the segment returned to Alabama to be frozen a second time to check. The finished surface is accurate to about 20 nanometers, and it is wrong. It is only right at 40 Kelvin.
The last thing done to the surface was to make it gold. In Morristown, New Jersey, each segment went into a vacuum chamber where gold was vaporized and allowed to settle onto the beryllium, a film roughly 100 nanometers thick, a few hundred atoms of metal. Across all 18 segments, NASA puts the total at about 48 grams, which is roughly the weight of a golf ball. Gold because of infrared. Webb does not look at visible light, it looks at heat, at wavelengths stretched by the expansion of the universe until they fall off the red end of anything your eye can do. And in that band, aluminium and silver are mediocre reflectors. Gold returns around 98%. Gold is also soft enough to mark with a fingernail, so a glassy layer of silica went on top, thinner than the gold itself. From that moment, the surface was never touched by anything again. And the gold was the cheap part. You could buy that much metal for a few $1,000s. What cost a fortune was the shape underneath it.
None of this fits in a rocket. The finished mirror is 6.5 meters across. The widest fairing available on an Ariane 5 is about 4.5 meters on the inside. So the telescope was built to fold. 3 segments on each edge hinged backwards like the leaves of a table, and a secondary mirror on the tripod that had to swing out and lock 1.5 meters in front of the rest. Behind it, the harder thing, 5 sheets of Kapton, coated in metal, spread to the size of a tennis court, 21 meters by 14. The front sheet is about as thick as a human hair. The others are half that.
They had to fly up folded like a paper fan, then pull taut without tearing, held apart so heat drains out the sides. The deployment needed 140 release mechanisms, 70 hinge assemblies, roughly 400 pulleys, and 400 meters of cable. The mission's lead systems engineer counted 344 single points of failure. Each had to work once, correctly, alone.
In 2018, during testing, the Sunshields covers tore. In another test, fasteners shook loose under acoustic load and had to be hunted down inside the hardware. An independent review board was convened, and the launch date moved again. It had already moved from 2007, then 2011, then 2018. The largest test of all happened in Houston, inside a chamber built in 1965. Chamber A at Johnson Space Center is a steel cylinder roughly 17 meters wide and 27 tall, and Apollo crews once sat in suits while the air was pumped out around them. For Webb, it was retrofitted with helium shrouds and taken colder than it had ever been. The telescope went in, and a 40-ton door closed behind it for about 100 days. Partway through, Hurricane Harvey stalled over Texas. Some places took more than 4 feet of rain. You cannot simply pause a cryogenic test. Warming the hardware takes weeks and risks it. So a skeleton crew stayed on site through the storm and kept the chamber running.
All of this caution has a source, and the source is a mirror that was polished perfectly. Hubble's primary was ground to an exquisite finish and the wrong prescription, too flat at the edge by about 2.2 micrometers, a fraction of the width of a hair, because a test instrument had been assembled with one lens sitting roughly a millimeter out of place. Nobody caught it on the ground. In 1993, astronauts flew up and fitted corrective optics, and Hubble went on to become the most famous telescope in history. Webb cannot be reached. It sits at a gravitational balance point about 1.5 million kilometers out, 4 times further than the Moon, and it was not designed to be serviced, which is why the strongest argument against it deserves saying plainly. For years, many working astronomers thought this was a bad bet. Costs climbed from early estimates near $1 billion to roughly 10. In 2011, a House committee voted to cancel it. It absorbed a decade of American astrophysics funding, and if one hinge had jammed, that is all it would ever have been.
It launched on Christmas morning, 2021, from Kourou in French Guiana. The Ariane 5 placed it on course so precisely that the propellant saved roughly doubled the expected mission life, past 20 years, against a design requirement of 10. Then came 2 weeks of unfolding, in the dark, at increasing distance, with no camera worth the name to watch it happen. 178 release devices fired. The sun shield pulled tight. The wings swung forward and latched. The cold side began to fall, and kept falling, until the mirror settled at around 40 Kelvin. Behind each segment sit 7 actuators that can shift it in steps of about 10 nanometers. The first picture Webb ever took was a single star in Ursa Major, appearing 18 separate times, 18 blurred copies scattered across the frame. Over the following weeks, they were dragged together and phased. On the 11th of March 2022, the 18 behaved as one. The error polished in on purpose had vanished, canceled by the cold. The mirror finally held the shape it was designed for.
The next time one of those images turns up on your screen, the cliffs of gas, the galaxies stacked behind galaxies, remember that it arrives through a mirror that would be useless on Earth, ground to the wrong shape on purpose, by people who would never see it work. If that is the kind of story you want more of, you know where to find us.